Hey everyone! Welcome back to our channel, where we make math easy and fun. We're going to break down the concept of limits, explore some intuitive examples, and solve a few problems together. By the end, you'll see how limits estimate the unknown and why they're a cornerstone of calculus. So, grab your notebook, and let's get started. Simply put, a limit helps us estimate an unknown value. We often play estimation games. For example, let's look at this sequence. 1, 2, 4, 5. I'm sure everyone has already figured out that the missing number is 3. Of course, that's not a limit. Now, let's solve our first limit question together. To explain the concept of a limit, I'll start with a graph-based question for you. Alright, let's talk about some terminology first. In a limit question, lim represents a limit. When you see lim x arrow 2, it means we want to find the limit of a function as x approaches 2. To approach 2, there are two ways, either from values greater than 2 or from values less than 2. We need to calculate both of these to determine whether the limit actually exists or not. Let's first approach the x value when it is less than 2. Approaching means we will get close to the function from the negative side or from values just less than 2. Then, we will approach the x value when it is greater than 2. If both of these limits are equal, we can say that the limit exists. Let's start by calculating the limit from the graph when x is less than 2. We'll observe how the function behaves as we get closer and closer to 2 from the left side. Look at the graph and focus on the values of the function as x approaches 2 from the left or from values less than 2. Notice how the function's values get closer and closer to 3. Next, let's focus on the values of the function as x approaches 2 from the right or from values greater than 2. As x gets closer to 2 from the right side, the function approaches 3. Let's note down this value for comparison. Since both sides approach the same value, we can say that limit exits and the limit of the function as x approaches 2 is indeed 3. Now, let's move on to a second example. If you'd like, you can pause the video and try to solve the question on your own first. For our next example, let's find the limit as x approaches 2 for this function. Remember to consider both the left side and right side approaches to see if they converge to the same value. Then we can say that the limit at exits at x equals 2. Let's start by looking at the graph as x approaches 2 from values less than 2. Observe how the function behaves as we get closer to 2 from the left way. Can see that the function values approach 3. Now, let's solve for the limit as x approaches 2 from the right side. Look at the graph as x approaches 2 from values greater than 2. Observe how the function behaves as we get closer to 2 from the right. The function values get closer and closer to 4. Since the limits from the left and right sides are not equal, we can say that the overall limit as x approaches 2 does not exist. Today, in this video, I want to touch on the concept of limits using a graph. We've learned that for a limit to exist at a specific x value, both the right side and left side limits must be equal. So, while the overall limit at specific x value does not exist because the left-hand limit and right-hand limit are not equal, we can still identify the behavior of the function. I hope this helps clarify how to determine limits from a graph. If you have any questions or want more practice, leave a comment below. Thanks for watching, and see you next time.